Yes, thank you for the introduction. I'm super excited to talk about the status. Um, Deborah, am I sharing charts or are y'all sharing? I can't remember. Sorry.
I will pull them up in a second because of the videos. It's taking a minute.
Oh,
Apologies.
thank you so much, Kristen. It's okay. Um, but I'm gonna tag team. Y'all haven't heard from Jake completely yet. We love tag teaming these presentations as a cross directorate, united NASA agency together. So he's gonna help with the first few slides, talking about how much we love the lunar surface and how all these things layer in our site selection status. So once those slides come up, we'll let Jake talk about the first couple constraints that eat our lunch a little bit and trying to narrow down that site selection.
Yeah, and I can just jump into it, and when the videos come up, we'll show them. And you know, yeah, Tamara and I work together in NASA, trying to understand the different constraints from the missions and what that means about where we might be able to land. And really, I think the most important thing to start out doing is making sure that everybody understands how the polar regions of the moon are actually quite different from the rest of the moon. That might seem inherently obvious, but the polar regions of the moon are also different from anything we know on Earth, including the poles of the Earth. So it's really important to drive home what we're really talking about when we say we're going to land in the polar region. Next slide, please. So the direction we were given was to land at the south pole of the moon. And so we made up this video a little while ago. A colleague of ours, Ernie Wright, made this for us just to show what we mean when we're talking about the sun and its impact on lighting at the moon. So basically everywhere else, once you start getting equatorward of 85 degrees, you start entering into the light cycle that most people are familiar with, where you have roughly 14 Earth days of continuous light followed by 14 Earth days of darkness. The lighting at the poles is a little different. The sun, because of the tilt of the moon, does not really go overhead. I like to say it dances along the horizon. And so what that means is the topography along the horizon casts very interesting shadows. So everywhere else on the moon, you have this repeated cycle. You have a repeated cycle at the pole as well. It's predictable. We can prepare for it, but it's not the same ratio, 50-50 light dark everywhere. You can have places that are permanently dark, never see sunlight, and places that are largely sunlit, meaning they are approaching 90%, maybe even exceeding 90% in some small areas, and any ratio in between. And what really is interesting is, because of the way the sun moves along the horizon, is that that ratio can change significantly over fairly short distances. So kilometers to even hundreds of meters, you can be in a very different ratio of light dark. And that's thinking about that ratio over a year. So that's one thing we want to point out right away that we have to take into account. Apollo understood the lighting and took advantage of it, landed early in a lunar morning, and knew they had 10-ish days of light to deal with. Next slide, please. There are seasons that we have to take into account. So what I like to point out here as well is that we want to be operating in light. Now, some objectives require us to operate in darkness. But when it comes to things like landing, especially early on, we want to land in sunlight so we can see the terrain. And so if you look at these patches that are in sunlight, I like to refer to them as oases of light. In the summer, the oases of light are large and they're fairly well connected, meaning you could even drive or move between them and largely stay in the sunlight. But as you move into the winter season, those oases begin to shrink, which means they become disconnected, and you really start to have isolated locations that are in sunlight. And that gets back to that ratio of sun to darkness that you have to take into account. The other main thing I like to point out on this slide is that the lunar seasonal cycle is not identical to the Earth cycle. What that means is that the lunar winter season will progress through the Earth calendar. So it's not as easy as saying, well, we just won't launch in the winter months here on Earth. Or, if we say these few months are not the easiest to launch, then we'll just avoid those. for launching to the moon, because the seasonal cycles are not the same. They will progress against each other. So it's another constraint we have to take into consideration. Next slide, please. And I think this hands back over to Tamra.
Yeah, thank you, Jake. So taking all those illumination aspects into account, we also have to look at that from that approach trajectory, right? Especially in these early missions, in order for the vehicle to really understand where it's coming for that landing accuracy, trying to get to that ellipse that we've selected. We want a certain percentage of that approach illumination in our early missions illuminated as well. So there's yet another constraint, right? Not just at the site, but on that traffic coming in to that area. So the red lines there, it's just a notional range, right? That approach trajectory shifts depending on that landing site and our trajectory. So there is a white paper out there on also safe and precise landing. Go check it out. And the sites that are listed there are part of Erwin Mazarico's paper in 2011. So it's a public study you can look at as well. Next slide. Continuing that layer, right? We got to understand that lunar surface and what those geospatial hazards are. And so there's a lot of assessments and mapping those landing ellipses. And, you know, are we looking at a landing accuracy of 100-meter radius or a 50-meter radius? You can see from this picture, if it's a 100-meter radius, you know, this site would be no-go because of that large crater. But you know, if it's a 50-meter radius accuracy, you know, we have a couple options within that. So a lot of work ahead of us and making sure we're really looking at those landing ellipses and accounting for all those risks, very similar to what Apollo did. Next slide. So this is another video to walk through. We talked about that illumination aspect, but now we're adding in kind of that Earth visibility. Now, the Earth visibility is not the same as, meaning we have direct to Earth comm, but it does give that idea of if we have that visibility, then it means we have direct to Earth comm. What you'll notice is that there's times when the Earth is visible, but we don't have the illumination, or vice versa. So in the middle of this video, towards the bottom, you can see a little, you know, red Rudolph nose. That's representative of if we landed at that site and kind of how small that site is versus all the things we're trying to look at from an illumination and those early missions trying to have that direct to Earth communication to reduce risks. Next slide. Continuing with that layering, there's multiple things that go into that mission availability. So we're talking a lot about those constraints when it comes to that site selection and site, you know, accessibility. But we also got to look at those right from the Earth, launch performance, the transit shadowing, transit performance, rendezvous, and communication on that whole end-to-end, all the way back to the crew landing back on Earth. So these are so many additional parameters that just layer upon layer that lead to kind of a launch calendar that narrows us in. And so it's a very challenging, not a problem, we're working it, right? But it's a challenging capability we're working through with all of these multidimensional aspects on our constraints. Next slide. Jake talked about our Apollo missions in the site selection and stuff. We also look at, you know, what's that illumination there on that horizon. We love looking back at our Apollo images and understanding how during those landing with these illuminations and we go to do those great spacewalks to go get really good science, what does that also play as a role in how we're looking at our technology and performing our mission. Next slide. So again, there's 2 white papers out there, lunar site selection and the safe, precise landing at the lunar sites. The other things that I can add for the team that folks may have heard rumblings on, when you look at all those constraints and they layer up and you have things like, you know, even weather launching on Earth, and now you can't get to that site because of direct to Earth comm or illumination. If you shift a month from an Earth launch window, it's now that site is no longer available on the lunar surface. We are looking at having multiple sites that help fill a full year calendar. It's not the greatest thing to pick a site and only have, you know, 1 month out of the year that it meets all those constraints that all those things stack up on. And so we're trying to also get through that challenge of how can we make sure when our vehicles are ready, when our crew is ready, it doesn't matter what time of the year it is, we can get to a lunar site and successfully land and perform some great science. So wanted to at least make sure folks started hearing that note as well on the early missions. It won't be just one site that we're planning to for a full year.